All right, good morning. It's Mr. Dorsey again. Out of the four worksheets that I posted yesterday, I did one already. Actually, I did it in two different videos, problems 1 through 5 and 6 through 10. This is the third worksheet. I'm going to write that here, third worksheet. I'm going to skip the second one. They are almost identical. And since this takes about 2 hours to render, it's kind of pointless for me to do that again. So I'm going to write this stuff down. I have another sheet of paper here. I'm going to write it on the top of each paper, and then that way you don't have to look through all my chicken scratches on every problem, okay? So this one does not have a box over here. It only has a box over here. So it's looking for what x equals or the final answer. So I'm going to go ahead and give you that. Again, the sum of three consecutive numbers is 126. So what are we looking at here? Well, and then it says, what is the smallest of the three numbers? That's what we're going to assign the question mark, or the x is the smallest of the three, okay? And then the sum, that means we're adding three numbers. And again, if you remember, let's take a look at this. If I have 1, 2 consecutive numbers, mean they go in a row like this, right? So the sum of three, all right, well, if one, just pretend for a minute, one's my smallest. 1 plus what is the next number? Oh, 1 plus 1. 1 plus what is the third number? Oh, 1 plus 2. So this is the same idea. This becomes x. That's our original smallest number. Think of that as like 1. And then my next consecutive number is x plus 1. And I'm putting that parentheses so you can see it's another number. Plus x plus 2. And then it says the sum is 126. So that means all three added together, 126. So one number, two numbers, three numbers. These represent entire numbers. First number, second number, third number. Now, because this is addition, this is like a 1 coefficient in front of the parentheses. So if I multiply everything in the parentheses times positive 1, it does nothing to change it. If this were minus, that's where we would get into some stuff where we would have to change the signs of this and this and this and this. But these are all addition, so we don't have to do that. Now, let me focus this again because it's not focused. Oh, there it comes. All right, close enough. Not sharp as a tack, but close enough. So now I can just remove the parentheses because of that, because it doesn't change any of the signs inside, so, or the operations. X plus 1 plus x plus 2 equals 126. And then what do I do with that? Again, if there were a box over here for the equation, this box would go in the, or this equation would go there, either this one or this one. And again, equation has the equal sign. That's where that comes from. All right, so now if we combine like terms, x plus x plus x, oh, that's 3x plus 1 plus 2 is 3. 3x plus 3 equals 126. Now, remember, I undo PEMDAS in reverse order. Bottom to top, I undo addition and subtraction, then multiplication and division. I have addition and multiplication. So I'm going to undo the addition first by subtracting 3 from both sides. That's a 0 pair. Now I'm left with 3x equals 123. Now I divide both sides by 3 to get x by itself. The 3's cancel. They become 1s. Right? That's what really happens when they cancel. 3 goes into 3 one time. 3 goes into 3 one more time. This becomes 1 over 1 times x, or x. That's why we did it. So this becomes x equals 120 divided by 3. You could do the long division, but I know 3 goes into 124 times, so that must be 41. Again, do the division on paper if you need to, or with a calculator. So my answer, this first answer in your box over here is x, whoops, not x plus, x equals 41. And again, I set my x, I assign my variable to the question. Okay, so that's problem 1. Let's look at problem 2. On Monday, these are exactly the same wording, just different order. So this is probably the only one of these worksheets I do, unless you want to have me work one out in particular in class. So here we go. On Monday, again, the day is inconsequential, but it's telling us a story. 274 students went on a trip to the zoo. All 5 buses were filled. In other words, there were 5 buses that they had available. Everybody got on, and there were still 4 students who didn't fit at maximum capacity for the buses. So those 4 students had to travel in cars. How many students were in each bus? So I'm going to assign that as X. So when I find out what X is, it answers the question, how many students were in each bus? So now let's look and see what this would be. I know I have a total of 274. I like to take whatever the total or the number there and put it on the right side of the equation. All 5 buses were filled and 4 students. So I have 5 buses times the number of students on each bus. So if it were 20 students, it'd be 5 buses and 20 students would be 100. If it were, 10 people fit on a bus, it would be 5 buses times 10 or 50. Okay, you get the idea. So that takes care of all the students on the buses, and 5 more students had to go in cars, so I have to add those 4. So my total number of students is 5 times the number on each bus plus 4 equals 274. This one becomes easy peasy. That's not F, that's PEMDAS. Remember, I do PEMDAS in reverse order. Bottom to top. I undo it in reverse order. So I undo addition and subtraction before I undo multiplication and division. So I'm going to subtract 4 from both sides because I'm adding in here. To get X by itself, I have to subtract 4. This is the 0 pair. These cancel. So this becomes 5x equals 274 minus 4 is 270. Now to get x by itself, I divide both sides by 5. If I multiply by 5, I divide by 5, and that gets x by itself. Those cancel. 270 divided by 5. So x equals, I'm going to try my brain ever so slightly. 54, I believe, is the answer. And again, you would have to, more than likely, and that's 54 students, you would probably want to do that on long division on paper or do it on a calculator. So my answer over here is x equals 54. Usually in a problem like this, you would answer whatever it says. You'd say like 41 is the smallest number, but because this is a teacher-made form, there's no room for that. I won't let you do that. And here you'd say 54 students. 54 students were in each bus. And you say 54 students in each bus. And I'm just writing that there just so you get the idea. You would do that every single time, but you would not, again, the teacher-made form does not allow you to do that. So that's why we're not doing it on every problem. All right, number 3. Joan bought a soft drink for $3 and 8 candy bars. The wording is not great on that, but she paid $3 for a soda, or a soft drink, which is a soda. She paid $3 for that, and then she bought 8 candy bars. She spent a total of $35. So of the $3 for the soft drink, she spent an additional amount on candy bars. So let's see what that is. She spent a total of $35. So again, I like to put the total on the right. And again, we're adding up the cost of things. So we know that she had 8 candy bars. So I'm going to put, how much did each candy bar cost? I'm going to assign X that value. We don't know what X is at this point. It's it's the price per candy bar. But if I take 8 candy bars times the price per candy bar, that's going to tell me how much she spent on candy bars. Plus, she spent $3 on a soda. The total of those 3 is 35. So 8 times the price per candy bar. Say if it was $1 per candy bar, she would spend $8. Plus 3 would be 11, but that's not what's going on here. Obviously, I have to solve for X. And the way we do that is, yes, please. I said by the time I do a new video, I would come up with something funny or creative for undoing this operation, but I did not. I guess I need to put on my thinking cap again. So let's take a look. When we undo this in reverse operation, I have to undo addition and subtraction before I undo multiplication or division. So if I'm adding 3, again, I want to get the variable alone. That's always my goal. If I'm adding 3 here, I must subtract 3 from both sides. 0 pair. The whole reason I did it was to get it by itself. So this becomes 8x. 35 minus 3 is 32. Hopefully most of you can see that in your head without having to do that on paper, but you sure can. Or you can do it with a calculator, but I hope you don't have to on this one. Sorry about the pinging. It's just like in class. The team is texting back and forth this morning. So there we go. All right, so now I'm left with 8x equals 32. To get x by itself, I divide both sides by 8, and I am left with x equals 32 divided by 8 is 4. Oh, there's my answer. X equals 4. And again, to answer that, each candy bar costs $4. That's what the actual final answer would be if you were writing this on the test. Let's go on to the next one. Tom spent half of his allowance going to the movies. Again, same wording, different numbers. So he spent half of his allowance going to the movies. He watched the family car, and earned $9. What is his weekly allowance if he ended up with $13? So his final answer, he wound up with $13 in his pocket. I want to know what his weekly allowance is. So I'm going to assign that the value of x. So when I solve for x, it'll tell me exactly the answer to the question. And if Tom spent half of his allowance going to the movie, he started with x, which is his weekly allowance, and he cut it in half, divided it by 2, and that's how much he had left, right? And then he watched the family car and earned $9 additional. So half of his allowance plus 9 gives him $13 left over, which is what that says. He ended with $13. So again, I'm going to write this down. I undo addition and subtraction first. Let's see if I can slide this up ever so slightly. I undo addition and subtraction first. So before division and multiplication. So I'm going to undo that. If I'm adding 9, I must subtract 9 from both sides. And that leaves me with, yes, you guessed it, a 0 pair here. X over 2 equals 13 minus 9 is 4. That's a 2. And then what do I do? If I'm dividing by 2 on both sides, I must multiply by 2 to get rid of it. The 2's cancel. X is left by itself on the left side, and 2 times 4 is 8. Yes. X equals 8, or $8, right? I would say his weekly allowance is $8. So, all right, and then see if I can get number 5 on the next piece of paper. Let's see if I can do it this way. Oh, I think I can without making too much of a mess. Tom sold half of his comic books and then bought 9 more. It's same problem, different numbers as we did in the first one. So if Tom, well, it says he sold half and bought 9 more. He now has 14. In other words, he's left with 14 on the right side of his equation. How many did he begin with? I'm going to assign that value to x, and I'm going to ask that question. Well, Tom sold a half, and he started with x, so he got rid of half, or divided his amount by 2. And then he bought 9 more, so he added 9 to his total. So his total, or his comic books he started with, cut in half, plus 9 is 14. And then all I have to do is undo PEMDAS in reverse order. I'm going to write it small because I'm running out of space. There we go. So I undo addition and subtraction before I undo multiplication and division. So this is undone first. If I'm adding 9, I must subtract 9 from both sides. That is a 0 pair. Right? This becomes x divided by 2. Oops, you're not going to see that. I'm going to move it up. X divided by 2 equals 14 minus 9 is 5. No, is that right? I did something wrong. So I can see what I did wrong, because usually it gives you, oh no, that's right. X divided by 2 equals 5. So now I was thinking that I would divide by 2, which would give me a a fraction, but I'm not dividing because I already divided by 2. I have to multiply both sides by 2 to get rid of the 2 on the left side to get the x by itself. The 2's cancel. X equals 2 times 5 is 10. Or in other words, Tom sold half, so X equals 10, or 10 comic books. He began with 10 comic books. Okay, that's the first one. So the first one, that's video number 1.